In this video, I will explain use the time convolution theorem of the Fourier transform. That is it is x1 of t convolution with x2 of t. Fourier transform is x1 of omega into x2 of omega. This is the convolution theorem. Use this theorem. Find the inverse and the inverse Fourier transform. Find the inverse Fourier transform of the function x of omega is equal to a plus j omega whole square. See the statement. Solution x of omega is equal to a plus j omega whole square. X of omega can be written as x1 of omega into x2 of omega. That is equal to 1 by a plus j omega into 1 by a plus j omega. Let x of t is equal to x1 convolution with x1 of t convolution with x2 of t. Now we have to find out x1 of t and x2 of t. We know that x1 of for the given problem, x1 of omega is equal to x1 of omega is equal to 1 by a plus a omega. x1 of t is equal to inverse Fourier transform of x1 of omega or inverse Fourier transform of 1 by a plus j. We know that e power Fourier transform of e power minus at u of t is equal to integral minus infinity to plus infinity e power minus at u of t e power minus j omega t dt. In the interval, u of t value is 1 for t greater than or equal to 0. That is 0 to infinity. The u of t value is 1. E power a minus t minus j omega t dt. These two are combined. For t greater than or equal to 0, that means 0 to infinity, the value of u of t is 1. 0 to infinity e power minus a plus j omega t dt. This is equal to e power minus a plus j omega by minus a plus j omega. 0 to infinity. For infinity, this value is 0 minus of minus plus for lower limit. Substitute 0 in place of t, that is 1. And finally, 1 by a plus b. Fourier transform of e power minus at u of t is, therefore, inverse Fourier transform of 1 by a plus j omega is e power minus at u of t. By using this one, we know that x1 of omega, x1 of omega is equal to 1 by a plus j omega. This for x1 of t notation, time domain form, Fourier for f inverse of 1 by a plus j omega. F inverse of 1 by a plus j omega is e power minus at 2 of t. This one is e power minus at u of t. That is equal to f inverse of 1 by a plus j. And similarly, x2 of omega is equal to same function. x2 of t is equal to f inverse of 1 by a plus j omega. F inverse of 1 by a plus j omega is e power minus at 2t. Therefore, x2 of t is equal to e power minus at. And x1 of t is also e power minus at u of t. Find out x of t. X of t is the inverse Fourier transform of 1 by a plus j omega whole square. X of t is x1 of t convolution with x2 of t according to convolution theorem. We know that x1 of t is x1 of t convolution with x2 of t is integral minus infinity to plus infinity x1 of tau x2 of t minus tau t2. Generally, x of omega is equal to 1 by a plus j omega whole square. This one can be written as x1 of omega into x2 of omega. Here, x of t is equal to x of t is equal to inverse Fourier transform 1 by a plus j omega whole square. But x of t is x1 of t convolution with, but x of t is x1 of t convolution with x2 of t. x1 of t and x2 of t is determined already. E power minus a minus t u of t and x2 of t is equal to e power minus a t u of t and x1 of t is equal to e power minus a t u of t. Minus infinity to plus infinity. x1 of tau, t is replaced with tau, e power minus a tau u of tau, and x2 of t minus tau means t is replaced with t minus tau, e power minus a t minus tau u of t minus tau d tau d2. That is equal to minus infinity to plus infinity e power minus a tau u of tau e power minus at e power minus at e power minus into minus plus a tau u of t minus tau d tau. E power minus a tau, e power a tau, these two are cancelled. That value is 1. Minus infinity to plus infinity, e power minus at u of tau u of t minus tau d2. Now you have to calculate this product value u of tau and u of t minus tau. U of tau. This one is u of tau, tau axis. U of tau value is 1 for tau greater than or equal to 0. 0, tau less than 0. This one is value is 1, u of tau. And for determination of u of t minus tau, we know u of minus tau. U of minus tau is like that. Hold. Minus tau, this one is tau. And u of t minus tau. T minus tau means this function is shifted. This function is u minus t minus tau. The value of u of t minus tau is equal to 1 when t minus tau greater than or equal to 0. T minus tau, t is equal to tau. The shifted function is here. T. This one is tau. Okay. Here, t minus tau is greater than or equal to 0. U of t minus tau is equal to 1. T minus tau is greater than or equal to 0 means t greater than or equal to tau. T greater than or equal to tau. Here are tau less than or equal to t. Here tau greater than or equal to 0. Tau greater than or equal to 0. U of t value is 1. Tau less than or equal to 2. U of t minus tau value is 1. Therefore, product of u of tau, u of t minus tau value is 1 when the value of tau is lies in between 0 and t. Because why? Because tau is greater than or equal to 0. Tau greater than or equal to 0. U of t value is 1 into tau less t less than or equal to tau. T less than or equal to tau. U of t minus tau. T less than or equal to tau means this region. The value is 1 to infinity. The value is 1. The value is 1. Therefore, 1 into 1 is equal to 1 when the tau is lies in between 0 to 0 to t. In this expression, minus infinity to plus infinity is replaced with 0 to t, 0 to t, and e power minus at, e power minus at, u of t and u of tau and u of t minus tau is 1 in this interval and d tau with respect to d tau. Therefore, e power minus at, e power minus at, integral of 0 to t 1 d tau. That is equal to e power minus at tau 0 to t. Therefore, e power minus at tau means t minus 0. T into e power minus at when t greater than or equal to 0. 0 to t greater than or equal to 0. Therefore, t into e power minus at u of t. This one is x of t. x of t is equal to, for the given problem, x of omega is equal to 1 by a plus j omega whole square. But inverse Fourier transform x of t is equal to f inverse 1 by a plus j omega whole square. Therefore, this x of t is equal to t into e power minus at u of. This is the inverse Fourier transform of x of omega is equal to 1 by a plus j omega whole square. With this, the analysis is completed. If you like this video, please subscribe the channel for further updates. Thank you.